Question 11. Below are 6 televisions and 6 remote controls. Remote 1 activates television A, C, and D. Remote 2 activates television B, C, and F. Remote 3 activates television A, C, and E. Remote 4 activates television E and F. Remote 5 activates all the TVs. And remote 6 might as well be a doorstop. It activates none of the televisions. A remote control is chosen at random. What is the probability that this remote control activates television B? So I made a little Venn diagram of this. I just drew a little circle for remote control 1. It activates A, C, and D. Okay, and then I made remote control 2, which activates B, C, and F. Okay, so 1 and 2 are going to have remote control C in common. See? It's right in between 1 and 2. And then remote control 3, A, C, and E. So I needed to get the A and the C into 3. So I put my remote 3 right here. And it controls A, C, and I put an E like over here somewhere. And then remote control 4, E and F. Remember, remote control 2 had an F, so I put 4 here, and then I moved the F and I moved the E, so it was both in 2 and in 4. And then remote control 5 activates everything, so I put everything inside a big huge circle 5. Remote control 6 activates nothing, so I put 6 out here. And you can put all this inside a rectangle if you like, but I didn't bother with that. What's the probability that this remote control activates television set B? Which ones activate television set B? Here's my B, and notice it's remote 2 and remote 5. That's 2 remotes out of the 6. Remotes 2 and 5 out of the 6 remotes, that's 2 out of 6, which is 1/3, or 0.3 repeating, or 33.3 repeating. A remote control is chosen at random. What's the probability that this remote control activates television C and E? What does C and E? C and E. Remote 3 gets both C and E, and the only other one that gets both C and E is remote 5. So we're talking about 3 and 5. So remotes 3 and 5 out of the 6 remotes is once again 1/3. 3. Television A, B, or F. A, B, or F. Remote 1 gets A. Remote 2 gets B. Remote 3 gets an A. So we're looking for A, B, or F. Remote 4 gets F. Remote 5 gets all of them except for 6 will turn on A, B, or F. Remotes 1, 2, 3, 4, 5 out of the 6. So that's 5 out of 6. 11B, part 1. Remote control 3, given that it activates television C. 3 given C. So we're looking at the probability of remote control 3 and C. What controls C? Well, 1, 2, and 3 control C. What does 3 have in common with that? Well, just the 3. That's just 1 remote out of 6, is what we're saying. Okay, what remotes control C? 1, 2, 3, and 5. That's 4 remotes out of 6. So we have 1/6 divided by 4/6, which is 1/6 times the reciprocal of 4/6, 6/4. The 6's cancel. We're left with 1/4. For B, part 2, remote control 1, given that it does not activate television F. Remote control 1 given not F is equal to the probability of 1 and not F divided by the probability of not F. 1 and not F. 1 is this. Not F is what controls F. Let's look at not F. What controls F? Well, 2 and 4 control F. So not F is everything but 2 and 4. 5 also controls F. 1, okay, oh yeah, doesn't control F. 3 doesn't control F. 6 doesn't control F. All right, so what does 1 have in common with this? Well, just the 1. So that's 1 remote out of 6, okay? And then the probability of not F, that's your 3 remotes out of 6. So 1/6 divided by 3/6, which is 1/6 times the reciprocal of 3/6 times 6/3, the 6's cancel, and that gives us 1 out of 3. Number 3, a remote control activates television E and F, given that it does not activate television B. We're looking for E and F given not B. So that's the probability of E and F and not B divided by the probability of not B. This is E and F, and this is not B. So which remotes don't activate B? Well, 4 doesn't activate B, 3 doesn't activate B, 1 doesn't activate B, and 6 doesn't activate B. Okay, so if we're looking at E and F, so which remotes activate E and F? 2 doesn't do E and F, 2 only does F, 3 only does E, so the only one that does E and F is 4. So this one does E and F, and not B. So what does this have in common with that? Just the blue dot, right? So this is 1 remote out of 6. Okay, and not B is this, which is 1, 2, 3, 4 remotes out of 6. So we have 1 remote out of 6 divided by 4 out of 6, which is 1 out of 6 times 6 out of 4. The 6's cancel. Once again, we get 1/4. 11C. Ali chooses a remote control at random and claims that there is a 1 in 6 chance that it will turn on all the television sets. Okay, he tests the remote control and activates television B. Has the probability that this remote control turns on all the televisions increase or decrease? Explain your answer. Okay, so we tested against one television, tested against television B. Well, what turns on television B? Remote 5, and that's what we're after, right? So there's a 1 in 6 chance that it's remote 5 before he turns anything on. He points it at television B and B turns on. How many remotes can turn on B? There's just the 2 remotes, 2 and 5. Now that it turns on B, we have a 50-50 chance that it's going to be, it could be remote 2, could be remote 5. We don't know for sure. Okay, so the probability just went up. But let's look at it using our conditional probability formula. So the probability that it's the universal remote, I just should have said remote 5. The probability that it's remote 5, given that it turns on B, is the probability of remote 5 and B divided by the probability of B. All right, so the probability of what does remote 5 have in common with something that turns on B? 5 turns on B and number 2. So what does 5 and 2 have in common? Well, just 2. Right? So that's 1 remote out of the 6. Okay, so 1 out of 6. The probability of B, okay, well, how many remotes turn on B? Well, 2 out of 6. So 1 out of 6 divided by 2 out of 6 is 1 out of 6 times 6 out of 2. The 6's cancel. 1/2. Look at that. So the probability has increased to 1 in 2, or 50%, or 1/2. And that's it for question number 11. Have a good day.